Alright, so now that we finished exercise 1, we'll go back to the same area and get the folder for exercise 2, and then we'll sit down and open that up. Now, I'm not going to go over the PPE all over again, but just to reiterate, definitely need to follow the directions on here. We'll set up your iPad, you'll watch the video completely through, and we'll have the iPad set up so at any point during the exercise you can refer back to it. If you get confused or whatever during the install, this is purely for your benefit, so when you go out in the field you'll have more of an understanding how just the basic material gets put together, and just take advantage of this time in this controlled environment. Alright, so just like before, we're going to go ahead and analyze the extra tools you're going to be needing. We've already gone over the drill, tape measure, and the screwdriver, so we'll just introduce the new items that are on the list. So let's go through. We got Sharpie, we've already done. So your roto split, we'll show you later in the video. It's used to strip the end of MC cable. Your wire strippers are used to strip the actual insulation off your conductors on the inside, and it's labeled for the size of the conductor on the inside, so you use that selection for the size of the wire you're using. This is a standard tool for every electrician. It's your linesman pliers, 9-inch. Everyone calls them Kleins as a nickname. These are diagonal cutters. And I didn't mention this on the first exercise, but these are the two main ingredients of any electrician: is a utility knife and some tape. Black tape you can use to, like, pull wire or whatever, but you'd always like to also have a roll of white or tape you can write on for labeling. Okay, so we're going to show you how to use the wire strippers correctly. So first, what you got to do is figure out what gauge your wire is. So the ground tails are all 12 wire gauge, so you would just look at the numbers on the wire strippers, and you see where it says number 12, you would slide your wire through there. Alright, so number 12 wire would go right in the number 12 slot. Use leverage to pull the insulation off. That way you don't have any nicks or abrasions on the copper. Okay, so we're going to go over the material used for exercise 2. I want to emphasize the importance of cleanliness on the cart. Always keep your tools off to one side and your material off to the other, and try to minimize the amount of material you have on your cart to just what you need for whatever task that you're involved in. I see a lot of carts that are just full with material. It's hard to know what you have. A lot of guys will order material that they have. It just might be hidden underneath mountains of stuff. I always try to at least organize what I got on my cart. If I'm using other stuff later in the week, that's fine. But generally, in this specific instance, let's organize everything just for what we need. So the first item is what we looked at before: 16-inch spreader bar. This is tie wire. We're going to be using to strap our pipes. This is called a CJ6. It's to support your cable. It's a NEC code requirement. Within 12 inches of any box, you need to use these supports. Tape. This is a 40 AST connector for single for your MC cable. Wire nuts. Splice your wires together. This is generally used for 12 wire and above. This is a ground tail. So all your boxes can be grounded. We'll go over that during the exercise of when we're actually installing. And this one right here is a duplex. It's a 40-40 AST connector. This is for a cable to go in and out of a box. So another tool we're going to need is the wire transporter and the bar that goes with it. This is to pull our cable easily. So that basically what you would do is you would turn the cable over, put the bar inside like that, and it's got different levels that you can put it on depending on the size of the wire. So you just line it up, make sure the cable's out of the way so you can roll right up on it, and then you just kind of guide it with your foot, get right into the groove. When you're ready to pull it off, easily, and like I was talking about before, you got the rotor split. whenever you want to strip your cable, you put it in there. It's got a little dial knob. Tighten it up just so it's snug. Then you can press down on it. So there's a blade in there that scores it. Just a couple times you'll feel it when it goes through. So you see that little mark right there? You just go counterclockwise, turn it, pull it, and kind of do a visual inspection to make sure it doesn't score the actual insulation off the wire. And then you're ready to put your 40 AST or 4040 on it. Okay, so we're starting to pull the cable. I want you to get a general understanding of how looking at a drawing works. So TCP1 is the name of your panel at the top. And the number in parentheses is your circuit breaker number. So if you open up your panel, they're labeled the odds on the left and the evens on the right. All panels are orchestrated the same way. So it's, like I said, the odds on the left. So circuit number 1 would be number 1 right there, and circuit number 3 would be the next one down. Okay, so the J signifies junction box. So if you look up, all our circuits go to this junction box. So TCP1, circuit 1, and circuit 3 all go from the panel to this junction. So once you turn power on, it's going to energize those circuits right there. So each line indicates a circuit. So TCP1 circuit 3 will be connected from the junction to this box, and then it jumps out to this box. It's the same circuit, circuit 3. TCP1 circuit 1 is what we call a dedicated circuit. It's just going to one location, straight to the junction. So from the junction to the box, circuit 1. So you would connect it to circuit 1, and if you look over here, the cable would go to this box. So remember we talked about this. This is 2 devices, so these are both connected together, which will be all on circuit 1. This box right here would have a jumper going through the studs to this box, then jumping out above the finished ceiling to the junction, which is circuit 3. So now that we went through the drawings and we've got a firm understanding of how it's circuited and how the cable's going to go, so we've already talked about this. This box right here jumps down to here. So when you look at the cable, we got it set up to pull. There's 2 different ways you can pull this thing. You can see how the ridges are going one way. Now you got to make sure you're pulling it through the studs the right way. This is orchestrated the way you want it to go, where you're going with the grain. See how easy that is to pull through? Now see when I pull it back, see how hard it is to pull back? So if we were to set up the spool backwards and have that the other way, you'd be fighting the studs every time. You got to make sure you're pulling the cable through the studs the correct way. See how much easier that is? Okay, something that we need to talk about. Say you got to go to break and you pull the cable, it's not connected into the box. You already got it here. One good practice, always label your cables. So, we'll just kind of roll it up like this so it's not hanging. Take your tape, and you already know the circuit number, circuit 3, TCP1. So you would label TCP, panel number 1, and then parentheses, circuit 3. That way, if someone comes back and has to finish where you left off, because you might get put on another task, break your tape a little bit longer than where you wrote it, wrap it around the cable like that. That way, no one needs to go back to the drawings. They already see that circuit 3, or it'd be a lot easier to just jump right back into the task. So let's go over how we connect into the box. So since we're coming up through the bottom, we'll go ahead and knock out the knockout on the bottom. Rule of thumb, we always like to use the outer holes, just in case if you have to come back in, it's a lot easier to go into the center. So since we have the accessibility, we'll go ahead and knock out the left side. So just bang the screwdriver a little bit, use a beater, don't use a real nice one. Twist your knockout out for 1/2 inch. You got your single AST rotor split, so just like we showed you earlier, we'll mark it, right around there. Let's go ahead and strip it. So squirt like that, counterclockwise. Okay, so you'll have an extra piece of plastic here if you want to take off as well. You know, at this point you can probably cut the wire down a little bit to work with, because you're not going to have this much to fold in the box. I generally like to take my thumb out like that once the wire is inside the box, and that's where we'll cut it. But you want to cut it a little long right off the bat, just in case. I'm going to cut this little plastic piece off. Now you're ready for your connector. Alright, so just put it in there like this. Snap it in so it's nice and snug, and you already got your hole, so you pull the wire through. Alright, snapped in. So this is what I was talking about. You got your wire hanging out this side. This is, you know, depending on your width of your, you know, drywall, you got to find out what your finished grade is. You could have 2 inches of, you know, hard wood. You got to talk to your foreman to analyze the prints to make sure you understand how much farther this dimension is going to be before you cut this wire. But in this instance, we know it's going to be 5/8 drywall. You would just take it like this. You got about a mark right there. Take your pliers, cut it. So now you're good. What I always like to do, separate the wires, because the ground's got to be connected to the ground tail, which is right here. So the easiest way to do this at this point is, we didn't go over this earlier. Loosen the chuck. We have a 5/16 nut driver. That's the same. See how it fits right in there, magnet. Go ahead, tighten that up, and there's a little hole on the inside here. This is where your ground tail goes. Okay, so now you're grounded. So all these grounds, you know, if you had another cable in there, you'd have another green, right? So you want to take all these greens and connect them together, because that creates a ground fault current path, which we'll go over later on. Okay, so what we talked about before about necessary supports according to our National Electrical Code and jurisdictional inspections. So within any box with MC, it needs to be supported by your listed means of support. So from your box, I generally go from the center of the box, make a mark at 12 inches. From any box, it's got to be 12 inches support. So I like to go a little bit before that, somewhere in that general area. That way the inspector doesn't have to pull out the tape measure. It's easily noticeable that it's within 12 inches. So you would unfold the CJ6 like that. Put our Phillips head back in. All right, so you just like take this piece and kind of go around the cable like that. Then you would just, I mean, you can use both holes, but you really only need one. But just for the sake of just showing you guys how this works, then you just fold it in like there, and there's a little tab, goes over, and you're all supported up. It's within 12 inches, easily seen by the inspector that it is. And then we can move on to the next step. So now that we do the single connector, we're going to go ahead and show you how to do a duplex. You already got the one wire inside. Push it off to the side. Make sure you get the space. Snap it into place. You got your CJ6, your means of support by the box. Go ahead and lock that in. All right, that's good. It's not stressing on the connector. So this is where you would do your grounds. Take your ground wires, separate them from everything. So the ground has to be continuous through your circuit, and the box needs to be grounded. So I like to push them off to the side. Now you're also going to need one going to your device, and this is why I left the wire a little long, so I can use this as a pig, what they call a pigtail. Cut them on the same length. Use your wire strippers. Go to the 12 wire mark. Strip the ends. So now this is your pigtail wire. Go into your device. Strip that. So now you put them all together to where the ends of the insulation where you stripped it is together. And this will take practice, but you just kind of loosely get them together. And as they start forming into each other, that's when you can start getting tighter. See how it kind of created a little groove there? And then I like to snip a little bit off. It's ready for the wire nut. Put the wire nut on, make sure it's not, the exposed copper is not beyond where the wire nut is. So at this point now you would fold it. So this is inside the box, and I like to push it off to the side so it alleviates and makes space for the device as it goes back. So to get this prepped even further, I'll take my hand and cut it, all the conductors a little bit longer than that. And then the same thing, you separate the whites and your blacks. The whites are the neutral, which is the silver screw on your device. The blacks are the brass screw on a receptacle. Cut them the same length. Cut them the same length. And if we're not putting the devices on right away, I like to just splice them together and put them in the back of the box. That way you can test the circuit for continuity later if you need to. Or safety-wise, if someone were to energize the circuit, you don't want exposed wires in the box. It's been known to happen where the wrong circuit has been turned on, and people have gone in the box and realized that the conductors were energized without wire nuts, and it could be a situation where you might get shocked. So I'll twist that together. But normally, these would be going directly on a device. You wouldn't want to spin these together like that. But then you would just put 2 wire nuts on them and push them in the box. Next, this is very important. Now that we're going to be using a ladder, I thought we'd take this time to go over a little bit of ladder safety. Now, this is a 6-foot ladder. It's a lean safe. That means we can actually lean this up against the wall like this to use it. You walk up it like this as long as you're facing the ladder. If you don't face away from it, that's illegal. You'll get dinged for that. But in this case, we're using it the natural way. You can't stand on the top 2 rungs of any ladder. You must be facing it like I said. So the feed for this circuit, as you can see, goes up the studs. It's supported again. With MC, it's I believe it's every 6 feet, but I have to check. And then you have a hole in your stud, and that's specifically there for us to get above the ceiling. So if you were to drill a hole here, and you brought it up on the outside here, that would be into the exposed area. You always want to drill through your stud to get up. You don't want to take it out here, because you would be able to see that cable at that point. After they put the drywall on in the ceiling, when everything's done, you look up and see that cable. So you want to make sure you get it up through the stud, through the top track is what they call it. Now, we're running the cable along the ceiling. A lot of times this is not wood, this is concrete, and there's a specific tool used to shoot these clips up. Concrete, but for the time being, we just use a wood screw to attach the L clip, and we can tie wire our cable nice and neat. And over here is our junction we talked about, where circuit 1 and circuit 3 is, which is labeled correctly. If these weren't labeled, we would have to trace it back. A lot of times the drywall is already up, very difficult to trace. A lot of troubleshooting, a lot of wasted time. So at this point, you would look in the box, you would test it with your tester to make sure nothing's energized. And we'll go over that on the next exercise, how to use the tester. But right now we're just working on the cables and how you put them in the box. So you snap it in, and this was circuit 3. We would then take the grounds and attach it to the ground bar inside the box, like the other one is from the feed. And then you would look for circuit, this one is circuit 3, so we would search for circuit 3, which is this group right here, and eventually we will tie this on to circuit 3 when we finish the rough end. And lastly, before you leave the work area, you always want to make sure you pick up all your scraps, anything electrically, because out of all the trades, you have the most slipperiest like debris, like cables. You'll slip. You know, GC's not looking for this stuff. We might be using the material every day, but every other trade's not going to be looking. Even like little pieces of wire like this, you step on that thing, you're slipping because this insulation's real slick. Even like little knockouts, even the strippings, I like to pick it all up. Best thing to do is make it look like we were never there. So this is the final stage of wall roughing, just the cable in the boxes. This is right before they're going to be putting drywall on. So at this point, your foreman where your crew leader will tell you to go check and make sure everything's ready for inspection. So like we talked about earlier, first thing you're going to want to look for is make sure you got your supports within 12 inches of the box. And then even though the code might require you to have 6 foot between the next one, if it's flopping in the breeze like this, go ahead and put an extra one on there. It's not going to hurt. It's going to look good for the inspector. He's going to want to see it. And it creates a better situation. If the drywall man's going to put his drywall, hopefully, it gives him more of a chance if there's more slack here to get sandwiched, because those guys don't care. What else we're looking for is the ceiling, like I was talking about earlier, making sure the cable's going through the stud, got your supports going up here. The ceiling you're not too worried about, because that's a totally different ceiling inspection, but you definitely want to make sure it's going into the right location, labeled correctly. Box is straight at the right dimension, especially ones that are right in line with each other. We talked about this earlier. Vertical laser, I'll get into that with another exercise, but that basically will make sure that you're completely straight vertically.